Today we're moving on in section 4.5, and the focus is going to be on graphing cosine instead of the sine wave. So we're going to start about talking about the general process to obtaining the cosine graph. You're going to notice that the process is almost identical to finding the sine information. The only thing that is different is the actual creation of the graph. So again, just to kind of review some concepts and to reiterate them, they are true for cosine as well. Remember, A, B, and C are numerical values. So the starting point for cosine is still going to be C over B. The amplitude is still A. The period will still be 2 pi over your B value. And lastly, we still find the period over 4 to determine what we're going to add every time. So notice this is still the same. Your x1 is still considered your starting point. But the only thing that's different is that x1 is no longer an x-intercept. It's either a max or a min, depending on what your a value is. If your a value is positive, so if a is positive, we would start at a max. If your a is negative, you start at a min. x2 will now become an x-intercept. x3 will be min-max. So if you started at a max, that means you're at a min. If you started at a min, that means you're at a max. x4 is back to the x-intercept. And x5 is back to the max and or min. So again, notice the main difference is not the actual obtaining the information. It will be the actual creation of the graph. So for our first example, we are going to do y equals 3 cosine of 4 theta. And again, remember, theta, x mean the same thing. So my a is 3, b is 4, and c is 0. So we don't have a c value. So my starting point will be 0 over 4, which is 0. My amplitude is 3. My period is 2 pi over my b value of 4. So this will reduce to be pi over 2. And then to find the period over 4, we take our period, which was pi over 2, and we divide this by 4. And remember, when we divide fractions, we keep change flip. So I'm going to keep the top of pi over 2, and I'm going to times by the reciprocal of 1 over 4. So what we're going to be adding each time is pi over 8. So this is what we're going to be adding to all of our x values. So my x1 value is 0, my starting point. My x2 will be pi over 8 because that's what we're adding each time. My x3 will be 2 pi over 8, which can be reduced to pi over 4. My x4 value will be 3 pi over 8, and x5 will be 4 pi over 8, which we can say is pi over 2. So now we need to get this information on the graph. Again, the actual graphing is what's going to be different. So same thing as before, we place our x values on the x-axis, and we put our amplitude on the y-axis. So we have a 3 and a negative 3. And I made each axis go, or each block go by pi over 8. The worksheets that you have, the axis is like already predetermined for you, so you have to figure out where your dot would fall. So again, the actual creation of the graph is different now. At our x1 value, we are either going to start at a min or a max, and because my amplitude is positive, we're going to start at a max. And then at our second x value, we're at the intercept. Our third value down to a min. Fourth value intercept. Fifth value max. So to create this, you almost want to think of like half of a sine wave, and then you have a full part, and then the other half part. and then this would continue, so this wave would continue and so on. So essentially it looks just like the sine wave, it's just we're kind of focusing in on a different part of the sine wave, we're cutting it off. The domain would still be -infinity to infinity for cosine, and the range for this example would be -3 to 3. So this is an example where the starting point 0, you have a larger amplitude. Next thing that we're going to do is an example with a problem that you have a c value, so that means you are shifting on the x-axis. So our next example is y equals negative cosine of theta minus pi over 2. So my starting point is going to be pi over 2 all over 1, because my a is -1, b is 1, and c is a positive pi over 2. Again, notice negative here, I wrote the positive over there. So my starting point is pi over 2. Amplitude is a -1. My period is 2 pi over my b value of 1, so 2 pi. And the period over 4 will be 2 pi over 4, which is pi over 2. So this is what we are adding each time. So my x1 value is pi over 2 this time. And this pi over 2 is coming from this fact right here of my starting point. So has nothing to do with what we're adding each time, that just happened by chance. So now I add pi over 2 to this, so pi over 2 plus pi over 2 would be 2 pi over 2, which is pi. x3 would be 3 pi over 2. x4 is 4 pi over 2, which is 2 pi. And x5 is 5 pi over 2. So again, nothing new here, it's just the actual creation of the graph. So now we're going to make our picture with this information. So again, I labeled my x-axis with my values. Each block represents a quarter of pi. So notice your graph is going to be a little bit more spread out this time. And our amplitude is 1 and a -1. So to get these values on the graph, again, your first x value starts at a min or a max. And since my amplitude was negative, I'm down at a min. At my x2 value, we're at the intercept. x3 value, max. x4 min, x4 was an intercept, and x5 is a min. So to create this, you don't want to make it look like a V. You want to make this part, the bottom part, kind of be concave, and then your convex, convex, and concave again. And again, this would be your sine wave, and this could continue on in both directions forever and ever, which means your domain is still -infinity to infinity, and the range is still -1 to 1. So that's all for today.